This will be the first one of two review videos for Chapter 3. We're going to try to graph three different parabolas given in different forms here. And in each one we're going to find the vertex, the y-intercept, the symmetric point, the x-intercepts, and the axis of symmetry. So on the first one, I'm going to find the vertex using x equals negative b over 2a. So negative b will be the negative of negative 2. 2 times a will be 2 times 1. So that's going to make the x-coordinate of the vertex be 1. To find the y-coordinate, we're going to plug it in for x. So that'll give us 1 squared is 1, minus 2 is negative 1, minus another 2 is negative 3. So we'll go to 1, negative 3, and we'll label that. Then we're going to find the y-intercept. So to find the y-intercept, we're going to plug in 0 for x. And when we plug in 0 for x, we'll get negative 2. So we'll label that point 0, negative 2. The symmetric point is going to be on the other side of the vertex from the y-intercept. So using the symmetry of the parabola, we can see that there'll be another point at 2, negative 2. That's what we're going to call our symmetric point. The x-intercepts here are going to be a little challenging because this doesn't factor nicely, so we're going to get stuck using the quadratic formula. So that's 2 plus or minus the square root of b squared is going to be 4, minus 4 times 1 times negative 2, that's 4ac, all over 2a. So that's going to be 2 plus or minus. The two negatives will make that a positive. 4 plus 8 is 12. We're going to need to break up that 12 into 4 times 3. And the square root of 4 is 2. So that's going to get us to 2 plus or minus square root of 3 over 2. We can split that fraction up and reduce each one. Remember, the 2 over 2 is not 0. That's going to be 1 plus or minus the square root of 3. Now, square root of 3 is a little bit less than square root of 4, which is 2. So 1 plus something a little less than 2 is going to be something a little less than 3. So I'm going to go a little less than 3. I'll put a big dot there. Call that 1 plus square root of 3 comma 0. And if we subtract something a little less than 2 from 1, we'll get something not quite to negative 1. So I'm going to go between 0 and negative 1 and call that 1 minus square root of 3 comma 0. We're going to get our nice parabola opening up and containing those 5 points. And we'll put our axis of symmetry down. And remember, that needs to be an equation, not just a number. So that's going to be x equals 3. Now, the second one, we have, because it's in vertex form, we're going to start by finding the x-intercepts. So we do that by setting this equal to 0. Since it's already factored, we can see we'll get negative 3 and positive 1. So we'll go to negative 3 and to positive 1 and label those x-intercepts. We can look and see halfway in between there is going to be x equals negative 1. That is going to be our axis of symmetry. We also can tell that the vertex has to lie on that axis of symmetry. It has to be halfway in between our x-intercepts. So we're going to plug the negative 1 in for x into our vertex form, or into our factored form rather. So that's going to be, I can get my pen back. So plugging in the x for the negative 1 for the x, we're going to get negative 2 times another negative 2. So that's going to be 8. So that is going to make our vertex be at negative 1, 8. 1, 2, 3, 4, 5, 6. 7 and 8. Didn't place that very well, so right up about there is going to be my vertex, and that's going to be negative 1, 8. So I'm going to see, I don't know if it'll still erase that. Nope, it won't let me erase that x equals negative 1. We'll just have to deal with it. So we've got so far our x-intercepts, our axis of symmetry, our vertex. We can find the y-intercept. So we're going to, again, as we always do for a y-intercept, we're going to plug in 0 for x. So that's going to be a negative 2. We have 0 plus 3 and 0 minus 1. So that's negative 2 times 3 times negative 1. So that's going to make our y-intercept be 0, 6. So let's see, 1, 2, 3, 4, 5. So roughly in there is going to be our y-intercept of 0, 6. And we can then see our symmetric point is going to be on the other side of the y-intercept, on the other side of the vertex from the y-intercept. So our negative 1, 8 was over here. I think I put that in the wrong place. And we're at 0, 6, so on the other side is going to be at negative 2, 6 will be our symmetric point. So that's the negative 2, 6. So did I get everything? X-intercepts, y-intercept? I think so. So we can draw our parabola that's opening down, like so. Okay, let's try the next one. This is now vertex form. So we're going to go right to the vertex because that's the easiest thing to see. It's going to be the hk in that y equals a times x minus h squared plus k. So that's going to make negative 2, negative 2 our vertex. That's going to be right there. I know it's going to open up because of the positive 1/2, so I can hopefully safely label that below. We can find our y-intercept. So to find, I got to watch where put my left hand there. So the y-intercept, we're going to plug in again 0 for the x. So that's going to be 0 plus 2 squared minus 2. So 2 squared is 4, half of 4 is 2, 2 minus 2 is 0. So that's going to make our y-intercept be 0, 0. Kind of interesting. That's also going to be one of our x-intercepts. And from the symmetry, we can get our symmetric point. Oh, we're really going to be fortunate here because on the other side of the vertex is going to be negative 4, 0. So that not only is our symmetric point, but it's also going to be our other x-intercept. And our axis of symmetry is going to be x equals negative 2. And so that's all we get because we kind of have two of these points doing double duty. The 0, 0 and the negative 4, 0 are both x-intercepts and our y-intercept and symmetric point. There we go. I'm going to go to a new screen here. And let's do, excuse me there, let's do a word problem here. So I'm going to pause it here and write it down. So we're challenged with finding the area of 3 rectangular adjacent pens, and we want to find the maximum area enclosed using 120 feet of fencing. Now on this one we don't get to use a barn or a river or anything as a side, so we're going to have to use fencing to get both of these longer sides there. So the area enclosed is going to be, well, let's see, we have 120 meters of fencing, or 120 feet of fencing, and we're going to subtract off 1, 2, 3, 4x. So that 120 minus 4x is the amount of fence we have left to make both of these longer sides here. So for those two sides, if we divide by 2, that's going to be the length of one of those long sides there, which we're going to need in the formula for the area. And in this carefully constructed problem, we can split that up and say 120 divided by 2 is 60, and the minus 4x divided by 2 is a negative 2x. So that is going to be one of those lengths. The area we know is length times width, and so that is going to make the area enclosed there the x times the 60 minus 2x. So we can see that that's going to be a parabola, and it's a parabola that opens down because of the negative x squared. So if we want to find the maximum area, we know that that maximum area is going to occur at the vertex. So we can use whatever means we want to find that vertex. I'm kind of partial myself to negative b over 2a, so I'm going to do that. The negative b will be the negative 60. 2 times a is going to be a negative 4. Negative 60 divided by negative 4 is going to be 15. So that's telling us that x is 15. We wanted dimensions, so our dimensions are going to be our length and width, and we can see that the width is the x and the length is that 60 minus 2x. So that means our dimensions is going to be 15 feet by 60 minus 2 times 15 is 60 minus 30. That's going to make that a 15 by 30 foot rectangle there. Okay, so let's do some different kinds of questions here. We're going to try to find the vertex by completing the square. And I'm going to give you a few different choices there, different kinds of problems. Find the vertex by completing the square. So to start with, let's look at something like y is equal to, and we'll say a negative x squared plus 5x plus 2. So to complete the square, we're going to start by factoring out whatever's the coefficient of x squared, and we're only factoring that out of the x terms. The plus 2 we're going to push outside there. It's not involved in the factoring. Now's the tricky part. We're going to take half of 5. Doesn't really matter the sign, because when we square it, it's going to be positive. Half the middle term squared, and that's going to be 25 fourths. So we're going to add 25 fourths into our parentheses. Now that is going to get multiplied by that negative 1. So adding 25 fourths in the parentheses changes the right side by a negative 25 fourths. So we'll turn back around and add that in to balance that equation. So now we have created something that will factor into a perfect square. It's going to be x, and because of that minus sign, it's going to be a minus, and we can take either the square root of the 25 fourths or the half of the negative 5. That's going to make that be 5 halves. We can get common denominators for these, so the 2 is going to become 8 fourths, plus the 25 fourths will make that be 33 fourths. There's our vertex form, and we're asked to find the vertex, so it's going to be a positive 5 halves and a positive 33 fourths. Let's try one with a little different twist. Let's look at y equals 1/2 x squared minus 3x, and we'll say minus 2. As before, we're going to factor out that leading coefficient, the coefficient of x squared, but only out of the x terms. Now, what's a little surprising, when you divide by a half, which is what you're doing when you factor, you're going to multiply by the 2, so that minus 3x is going to become a minus 6x, and the minus 2 just hangs out. We're going to take half the middle term squared. Half of 6 is 3. 3 squared is 9. That 9 is going to get multiplied by 1/2, so we have added 9 halves to the equation. We'll turn around and subtract it back off so that the net change is 0. Now this is going to factor into a perfect square. It's going to be x. That'll be a minus because of the minus 6x. And half of 6, or square root of 3, are going to agree as 2. We're going to get a common denominator, so 2 is 4 halves. So that'll be a minus 13 halves, making our vertex a positive 3 and a negative 13 halves. And I think I'll stop there for this video.